and I thank agricultureinformation.com for giving me this opportunity. This is the fifth webinar I'm conducting on micro irrigation knowledge sharing for farmers. And today's topic is how we will have to design an economical sprinkler irrigation system. So let us understand the layout of a sprinkler irrigation system. So like a drip irrigation system, a sprinkler irrigation system has got three main components, as you can see. You have a head control unit where you have a pumping pump. Without the pump, the sprinklers will not work, or you need gravity pressure, followed by the water conveyance or the main line, and followed by the water distribution, which are the laterals and the sprinklers. A sprinkler irrigation system is relatively simpler system in terms of the layout. So you can see that there are a number of sprinklers which are shown here in this photograph, courtesy of the Pradhan Mantri Krishi Sinchai Yojana. So you can see that you might be finding some components like screen filter and QRC and all that. Don't get worried. So basically it's all systems have to have a control unit followed by a water conveying system, and then the water has to get distributed. And instead of water flowing through the drippers, you're going to have the water flowing through the laterals and the sprinklers. So that is the only essential difference that you actually over here have. Now let us look at the various types of sprinkler irrigation systems that are actually in picture. So the various types of sprinkler irrigation that are there in the picture, you can actually make out. So you have the portable sprinkler irrigation system, which is the most common sprinkler irrigation. It has a typical coverage radius of 12 to 18 meters. And typically the application crops are cereals, oil seeds, pulses, millets, maize, and field crops. So basically you can have a brass model type of sprinkler, or you can have even a plastic sprinkler. Coming to the second one, that is called the micro sprinkler. These are basically small sprinklers. Why they are small? Because you're going to have a lower radius. The radius is between 10 to 20 feet or 3 to 6 meters. Typically, these micro sprinklers are very popular to irrigate vegetables, ginger, nursery, flowers, fruits, greenhouses, anywhere that you go. One advantage of a micro sprinkler is not only will it provide irrigation water, it will also create what is called as microclimatic control or humidity control. So when the water is sprayed in the area, so automatically the temperature is going to come down because it is going to increase the humidity. And the third thing that we are going to see is the mini sprinkler system, which typically falls in between the portable and micro sprinkler. So the mini sprinkler has a radius, typical radius from 6 meters to 12 meters. And typically micro sprinkler is a very popular product, particularly in Gujarat, Maharashtra, Karnataka, for onion, potato, field crops, and many places in West Bengal and other areas. We also use it for paddy, wheat, and other field crops. So basically we are going to look at the number 2 and number 3. That is, we are going to look at the design of a micro sprinkler system and a mini sprinkler system. The portable sprinkler system is basically a set of 30 pipes with 5 nozzles given, and that is just the farmer has to fit it and take it. So there is no really a design in that. Now let us look at what are the objectives in designing for a sprinkler irrigation system. First and foremost, any design should be economical for the farmer. Second, it should be easy to install by the farmer, and the installation cost and the fitting should be very simple. Third, most important one will be that it should be efficient. Efficiency in terms of water distribution. The water, when we design the system, the water should be divided across the field with a 10%, maximum 10% discharge variation, which is stipulated by the Government of India. And water has to be given to the crop as per the crop water requirement. A smaller crop or a younger crop will require lesser water, and as the crop becomes bigger and bigger, you will have to give a greater quantity of water. So all of you are aware of this from my earlier webinars. And in sprinkler irrigation, like drip irrigation, the soil type becomes very critical. So it is very important to understand how the water is going to be sprayed, that is the application, and how the water will be absorbed by the soil. Like, if it's a sandy soil, the water is going to directly get infiltrated. Whereas if it is going to be a clay soil, the water can run off. So we must irrigate to such an extent that the water will not run off, or not will it infiltrate so fast or go deep inside, so that you avoid under or over irrigation. So this is very critical. And finally, it should be easy to maintain and design. And you can also have the design in such a way that if you want to expand to a future area, it is always good design engineering practice to ensure that the main line is adequately sized so that you can have an expansion in the future areas. Now let us now get into the design of the micro sprinkler irrigation system. So as you are seeing over here, The micro sprinkler irrigation system is a very simple system. You have a sprinkler head which has got a rotating swivel, as we call it over here. And as I will just show it to you how it rotates. So when you blow it, this central part is just simply going to rotate. So basically, this is the sprinkler irrigation system. The water will be sent in through a tube, and from the tube, it will hit over here, and the swivel will rotate. So this is a micro sprinkler irrigation system. Now let us see what are the design parameters for the micro sprinkler irrigation system. So, and the application of the micro irrigation system is, it, like I told you in the beginning itself, it can be used for irrigating nursery beds, shade houses, greenhouses, poly houses, even for closely spaced crops like ginger, garlic, leafy vegetables, cauliflower, cabbage, carrot, radish, beetroot, potato, onion. It's a very popular product, and it's very easy to install and easy to design also. When we do the design, there are three important parameters of any sprinkler. What are the three important parameters? We should know at what pressure you want to operate that product, that micro sprinkler. Second, at that pressure, what is going to be the flow? And third, when I give the required pressure and the discharge, what is the area or the wetted? Because you know the sprinkler throws in the form of a circle. So what is the area that it is going to cover? So when we talk of a circle, we are looking at the radius. So what is the radius or the diameter? For example, if I take in this chart, if I take the recommended operating pressure of 1.5 kg per square centimeters, it is going to have a flow rate of 100 liters per hour, and the wetted diameter is going to be 7.8 meters. Or in other words, it should have a radius of around 3.9 meters. So this is the first important thing, that when any sprinkler design, please understand what is the pressure, what is the flow rate, and what is the diameter. So once you know this, then you can get into the next step. In the next step, we will have to calculate what is called as an application rate or a rain rate. That means if I operate the sprinkler or a set of sprinklers for 1 hour, how much water is it going to give in millimeters per hour? So this calculation is very critical, because if you're going to give a higher application sprinkler in an area where the water is going to be where the soil is going to be a clayey soil, then the water is going to run out. You will have to match your application rate based on the soil type. So for example, I am just telling you how to calculate. In order to calculate the application rate, there is a very simple formula. The formula to calculate the application rate is, take the discharge of the sprinkler in liters per hour and divide it by the grid spacing. So here, for example, I have taken the discharge of my micro sprinkler is around 100 liters per hour, and the grid spacing, that is 3.5 into 3.5. So if I do the calculation, I will get 8.16 millimeters per hour. In order to make it clear, I have just made one more sketch for you. Now this is the micro sprinkler. When they throw it, it will throw in the form of a circle. So both the spacings are given. So over here, discharge of this micro sprinkler, I told you, is 100 liters per hour. And in the north, south, and east, west direction, that is the grid spacing is 3.5 into 3.5. So 100 liters divided by 3.5 into 3.5 will give me 8.61 liters per hour per square meters. I have explained in my earlier sessions also to you that 1 liter per square meter is nothing but 1 millimeter per hour. Going by that calculation, so 8.16 liters per square meter converts to 8.16 millimeters per hour. So that is the basic understanding. So how does this translate into an area? Let me consider two examples. One is a 1 acre area and one is a 1 hectare area. We know 1 acre is nothing but a 64 meter by 64 meter. And I have taken a square plot for convenience. We understand that the micro sprinkler is going to throw 8.16 millimeters per hour. And I told you that 1 millimeter is nothing but 1 liter per square meter. So what will be the water applied in 1 hour? I need to knock off the square meter. So I just take 8.16 multiplied by the area, that is 47, which is the area of 1 acre. I will get 33,023 liters per hour. That means if this sprinkler system operates for 1 hour, it is going to consume 33,023 liters per hour. That is the meaning of this. Same calculation if I take 1 hectare and the same application rate of 8.16 millimeters per hour, then what will happen? What did I do? I took the same application rate. Instead of 47, I'm multiplying by the area of 10,000. So it becomes 81,600 liters per hour of water needs to be given for this particular area. Now I did this calculation. How is it useful to me? Now I know that I have, for example, let me take the first 1 acre. There is a vegetable, maybe a cabbage, requires 5 millimeters per day on a cool day. So from this application rate, I will be able to find out the number of minutes or number of hours I need to irrigate. How to do that? I know that I need to apply 5 millimeters per hour, and my product is going to give me 8.16. So 5 divided by 8.16 will give me 40 minutes. So that means to give this precipitation or application or the rain rate of 5 millimeters, I have to operate it for 50 minutes. Now, if I take this 1 hectare plot and it is in a, I want to irrigate the same vegetable, but it is in a hot place. It's very hot day or a hot place, and I need to give 7 millimeters per day. Then how many hours will I have to irrigate? So 7 divided by 8.16, because we have fixed up the application rate of the sprinkler. So here I will have to operate it for 7 divided by 8.16, which is about 52 minutes. So you will understand it's very simple logic that as the if the day is cool, then the number of minutes that you have to operate the sprinkler system is going to be less. And if it is a very hot day, I will have to increase the number of minutes for irrigation. Now, this chart I had already shared to you, but I'm just extending this chart. In order to do the design, we will need to know how much each of our tubing, that is our water carrying pipes, that is whether it is the main system, main water carrying system, or the distribution system. So as you know that our linear low density polyethylene pipes or LDP pipes are used, and we have it in standard 16, 20, 25, and 32. I am just for the convenience, I have shown you other thing. And what is the water carried? 350 to 370 liters per hour for a 16 millimeter. And for 20 millimeter, it will be around 550 to 600 liters per hour. And if it is a 32 millimeter that you are going to use as your distribution tubing, it is going to be 1600 to 1800 liters per hour, or the lateral line, which is very commonly called. Then you know that we have to design even the sub-main. Basically, we are doing a selection. So if I start with the smallest diameter 40 mm, you know it will carry around 4000 liters. 50 mm will carry roughly around 8000 liters. 63 mm may carry around 14,000 liters, and 75 mm 21,000 liters, and 90 mm around 32,000 liters, and 110 mm around 44,000 liters. This part I had already explained to you in my earlier session, the session number 4 on drip irrigation design. I'm just repeating the same thing just for us to do the selection. So when I did this approximate chart, so basically I have considered the following. What are the assumptions I have made? The maximum velocity of flow that we will allow in the PVC pipeline or in the lateral will not exceed 1.5 meters per second. And second, we will restrict the friction loss in the pipe not more than 2 meters per 100 meters. Why do we do that? Like I explained to you, you'll have what is called as water hammer. Water hammer means water will come and hit, and you will have a rebound, and when the rebound is there, you could have leakages from the joint. So basically, we want to send the water in a very smooth way. And for HDP, whatever limits that are shown, you can increase it by another 15 to 20%, because the velocity that we consider in a HDP design will be 1.7 meters per second. If you want to do a very accurate calculation for small plots, this spot design method is very convenient. If you want to do a very large design, then you will have to go for either the charts, or you can go for the IRRICAT design or the Hazen-Williams equation, which I had already explained to you earlier. Now let us look at the example number 1. This is a micro sprinkler example, and let us look at the farm information that I have collected. The dimensions of this plot is 80 meter by 50 meter. The water source to this plot is a bore well, which has got 7,200 liters of output, which it is fitted with a 5 HP 8-stage submersible pump, and the depth of the bore well is, that means the submersible pump has been installed at a depth of 30 meters, and the outlet to that bore well is around 2 inch or a 50 millimeter. And the water quality is normal water quality with minimum swift. And the crop that I want to irrigate with this micro sprinkler is ginger. And I now have to decide what should be the grid of the micro sprinkler. I showed you the various combinations. You have 3 meter by 3 meter, 3.5 by 3.5 meter, and 4 meter by 4 meter. For the sake of easy design, I have taken, okay, the soil is of a sandy loam, and I would like to have adequate overlap. But generally, a head-to-head overlap is considered. So I am taking a grid spacing of 4 meter by 4 meter. So now, like the design of the drip irrigation system, I will follow the step-by-step procedure. So step number 1 will be to select the system based on the crop. My crop is ginger, so I will consider the micro sprinkler irrigation system. Second, I will have to go for the grid. What is the grid? What is the meaning of the grid? North and south and east and west, how am I going to place the micro sprinkler? So it is going to be 4 meter in the north south and 4 meter in the east west. So I'm going to have a grid of micro sprinklers spaced 4 meters by 4 meters apart. And at 1.5 bar or 1.5 kg pressure, this micro sprinkler gives a discharge of 100 liters per hour. So this is the basic grid selection and the system selection. Now coming to the third step, we need to know, can I irrigate this entire area in one shot or in one block, or do I have to make blocks? How do we do that? Like the drip irrigation, we will have to calculate over here how many micro sprinklers are going to be required for this area. We know that the area of this plot is a 1 acre, that is going to be 4,000 square meter, and the grid spacing is 4 meter by 4 meter. Therefore, the area divided by the grid spacing will give me the number of micro sprinklers, which works out to be 250. And you know that every micro sprinkler is going to give me a discharge of 100 liters per hour. So what will be the total discharge? 250 multiplied by 100, that is around 25,000 liters per hour. Now the water that is available in the bore well is very, very less. It is only 2 liters per second. So 2 multiplied by 3,600 gives me only 7,200 liters per hour. So what is it trying to tell you? The discharge that is required to irrigate all the micro sprinklers, all the 250 micro sprinklers, is 25,000 liters. But the water that is available with me is only 7,200. So what should you do? That means I have to create small sub blocks. So basically blocks I have to create. How many blocks do I have to create? I know I require 25,000. You divide it by the water that is available in the borewell. So 25,000 divided by 7,200, I'm going to get 3.47. Normally we don't make a uneven block. We will make, okay, we'll round it up to 4 blocks. So here basically I have, this step is very important. How many blocks I have to create for this particular plot based on the availability of water. So here I have shown you the layout. This is the 50 meter by 80 meter plot, and the borewell is around 20 meters away. So I have created 4 blocks. At this stage, I do not know the size of the main line. I do not know the size of the lateral. I only know that I have made it into 4 blocks because my design and water availability dictates that I have to have 4 valves. So I have just put in the valves. I have made 4 equal blocks for the sake of water distribution to be uniform. So I have just created valve 1, valve 2, valve 3, and valve 4. So I have just created 4 simple blocks. Once I have done this, then like I told you, the design always starts from the last. So from the micro sprinkler, what is the micro sprinkler connected to? It is connected to the lateral. So when I come to the lateral, I have combination. I have a 16 millimeter lateral, I have 20 millimeter lateral, I have the other sizes. So what should I select? Should I select a 16 or a 20? So to do that, I have to check how many micro sprinklers are going to come in one row. In one row, we know that the entire, in the earlier you have seen that was 80 meters. So in the entire row, 80 divided by 4, you are going to have 20 micro sprinklers from one end of the plot to the other end. And if you take the discharge of each micro sprinkler as 100, so 20 into 100, in every lateral, 2000 liters per hour, 20 multiplied by 100, 2000 liters per hour of water has to flow. But we know we have made 4 blocks. So we have made 4 blocks. That means what is the maximum running length? It is not going to be more than 20 meters. So basically what is happening? We need to know what is the water that is flowing only in the 20 meter length. So 2000 divided by 4 parts. So basically you get 500 liters per hour. So 500 liters per hour, what has happened? It has exceeded the carrying capacity of a 16 millimeter lateral, which is not more than 400 liters. So it has gone into 500 liters. So therefore we cannot select a 16 millimeter lateral. We will have to go for the next size, that is 20 millimeter lateral. So that means I have now finished the second part of the design, that is to design the lateral. I am going to go for a 20 millimeter lateral, and I'm going to have the micro sprinklers at a grid of 4 meter by 4 meter using the 20 millimeter plain lateral. Once this has been done, the water from the micro sprinkler gets into the lateral. From the lateral, it is getting into in the reverse way. So it is getting into the submain. So submain, as you know, it can either be HDP or it can be PVC, whatever is the thing. Typically for the micro sprinkler system, the farmers use both HDP as well as the PVC pipes. So if we are recommending generally the HDP pipes. So what is the discharge in each submain? We just need to know, because we have made 4 blocks. What is the total number of micro sprinklers? We know that each block is going to have 62, because 250 divided by 4. So you are going to get roughly 62 numbers multiplied by of the discharge of each. So it will become 6,200 liters per hour. But we know that the borewell available water, when you switch on the borewell, the entire 7,200 liters is going to get in. So here you have a choice, because this 7,200 liters per hour is the border line. You can either use a 50 millimeter or you can go for a 63 millimeter. And like last time, in order to make the design economical and also to give the right kind of velocity, we will go for what is called as a telescopic submarine design, where the first 50% will be 63 mm, followed by the balance 50% with a 50 millimeter or a 40 millimeter pipeline, as the case may be. And why do we do that? Because the water is maximum at the beginning, and as it keeps flowing, it will taper off, and you will have to get the minimum flow at the end of the submain. So basically, you are going to do a telescopic design starting from the maximum flow to the minimum flow. So that is how we have completed the submain design. Once the submain design has been done, then we have to go for the main line. You know that the water, maximum water that is flowing in the borewell is 7,200 liters. And here what I suggest is, if you are going to add one more borewell, you can go for one mainline size higher. For example, 50 millimeter would have been enough, but now we will go for a 60 millimeter, 63 millimeter, 4 kg pressure rating pipe. Once that is completed, since it is a micro sprinkler and the water may contain silt particles and other sand particles, we need to filter it, and therefore we will go for the filter selection with a 2550, a plastic screen filter, a very simple screen filter of 2550 means over here 25,000 liters per hour capacity, and a 50 millimeter inlet and outlet, so that the water particles don't go and block the nozzle of the sprinkler. Now we will come to the last part, that is the head loss calculation. Now we have done the design. So what is the design? We have selected 100 liters per hour micro sprinkler, and we know what is the size of our lateral, that is 20 millimeter. And also we know what is the size of our main line and sub main line. Now we will have to check whether the existing pump over there is capable of delivering the water with the desired uniformity. So for that, we need to calculate what is called as the total dynamic head or the head loss. So for that, the first head that we have to consider is the operating head for the micro sprinkler. Micro sprinkler requires, we have selected 15 meter. Drip would have been 10 meter. Here I have selected 15 meters. And what will be the head loss that will happen in the submain as well as the lateral? Normally it is 10% of the operating head. So 10% of 15 meters works out to 3 meters. And the motor is sitting at a depth of 30 meters. In other words, I have to bring the water from a depth of 30 meters, and I am going to pass this water through a filter. Whenever I pass water through any kind of obstruction, that is going to create a friction loss. So screen filter will create a loss of 2 meters. And if I am going to provide a venturi, and if you want to do the fertigation, in that case, I have to add on the 5 meter of venturi also. And then head loss, what will happen in the fittings and accessories, it will be between 2 to 3 meters. And mainline loss will be 2.5% of the mainline length. So that you already have understood in the earlier thing itself. So basically, what is the mainline length? You have to see the distance from this bore well right up to this last point, that will work out to 85 meters. So that distance you can take, and whatever is the mainline length you can calculate. So that 2.5% works out to 3 meters. And elevation, no plot generally has, there will be a minimum elevation. So I have taken around 2 meters. So the total head, when I total up all these head that is required for the system to work correctly, you require around 63 meters head. So once I've got the total head, then what I can do is, then I can go for the pump checking stage. So the pump checking stage, so here what will happen is, you know that it is fitted with a submersible pump, and the submersible pump, it has got an 8-stage pump, and there are 8 stages, means you can make out over here, there are 8 cups over here. These are the impellers. So like I told you, if it is an old model pump, that generally typically one stage can lift up to 9 meters. So 8 into 9 will be 72 meters. So the head available in this particular pump is roughly around 72 meters. But the head required from the previous step that we have calculated is around 63 meters. So the existing head pump is definitely sufficient in terms of the head that is required. So existing submersible pump is suitable from the head point. Now, is it okay from the horsepower point? So let us do that check also. The horsepower formula to calculate the horsepower of any system is given by the formula. The discharge multiplied by the head divided by 75, which is a factor, multiplied by the efficiency of the pump and efficiency of the motor. So if I put in the formula, so actually 0.7 into 0.8 is 0.56. I made it as 0.6. Typically, Indian centrifugal monoclop pumps have an efficiency varying from 56% to 60%. So I have taken 60%. The discharge is around 2 liters per second, and the total head required is 64 meters. So 2 multiplied by the head or divided by 75 into 0.6, you are going to get a HP of 2.8. So the existing HP is in fact more than enough. In fact, you will have excess water. In the excess water, if you are going to get excess water, you can maybe try to operate 2 valves at a time and see if the entire area is able to be irrigated. So this completes the micro sprinkler design example. Going on now to the mini sprinkler. So mini sprinkler basically is a bigger sprinkler, like I told you. So here the mini sprinkler, essentially what is the difference? So these are all sprinklers which will have two nozzles. So the earlier sprinkler had one nozzle. This has got two nozzles. You have the smaller nozzle which will cover the area around the sprinkler, and you will have a nozzle which is covering the farther part of the sprinkler. You can see that actually in operation. And where is it useful? This mini sprinkler is a very widely used product, particularly for the onion and potato. Why is it for onion and potato? Because it is very useful in germination and chilies and groundnut. So like I told you, like any sprinkler system has got many advantages, like it will clean the leaves, it will give microclimatic control, it will throw water all around. But at the same time, you should use it judiciously based on the crop. If the crop spacing is very close, then we can go for this kind of product. And it has been seen it can be used for crops like potato, chilies, groundnut, mustard, cauliflower, cabbage, leafy vegetables. It is also useful for germination and frost control. You know what happens in cold countries? What will happen when the temperature freezes? Then the plants will have a problem of the temperature. If you sprinkler irrigate a crop, the water will fall totally on the leaves of the plant, on the entire thing, and when it forms icicles, further the temperature in the plant will not come down. So the plant is protected from getting further thermal shock, and it's all over Europe and wherever, like place like Kashmir or any other place where the temperatures drop, it's a good practice to go for sprinkling just before the onset of the winter season, so that it will be helping for the frost control. In addition to that, I like a micro sprinkler, a mini sprinkler also will help you to have a microclimatic control by increasing the humidity and decreasing the ambient temperature. Now to do the design, it is exactly similar to the micro sprinkler. It will be a good revision for you to understand. So this is the the mini sprinkler specification. So at various pressures, the three important parameters: pressure, flow, and diameter. So at 1 kg, it is going to give 386 liters per hour, and the diameter that it is going to cover is 17.5. If you are going to increase your operating pressure to 1.5, it will have a flow rate of 475 liters per hour and a better diameter of 18 meters. Then this is the recommended operating pressure. You can increase the pressure if you have a bigger size pump. So the advantage is, as you increase the pressure, it will also cover a larger radius. So this is the range. So it starts from 17.5 right up to 19.5. But for the design sake, we generally take a 1.5 because many places the farmers don't have that much pressure. So we can go, in case you have a better pump, then of course you can always select the appropriate pressure that is available. Once that is done, again we'll have to calculate the application rate or the rain rate. How to calculate the application rate? Simple formula. Take the discharge in liters per hour like the earlier. So how much is the discharge of this? I have selected a grid of 9 meter by 9 meter. For the sake of convenience, for this particular crop is onion, and I would like to have a 9 meter by 9 meter grid between the sprinklers so that adequate overlap is there. Operating pressure, I'm going to keep 1.5. So what will be the application rate? Very simple. Take the total discharge divided by the grid spacing. The grid spacing is 9 meter by 9 meter. So 475 divided by 81 will give you 5.86 millimeters per hour. That means in 1 hour, you are going to give a rain rate of 4.86 liters per square meter. So again, you have to understand this in terms of converting the millimeters per hour into the amount of water that you have to apply for 1 hour. So if I take the same example of 1 acre, an application rate of 5.86 millimeters per hour, it means that you are going to apply 23,698. How did I get that? 5.86 multiplied by the area. So that is basically because 5.86 liters per square meter multiplied by square meter, meter squared get cancelled. What will remain is only the liters. So 5.86 multiplied by 4047 will give me 23,698 liters. Now, if the plot is going to have a vegetable and you want to finish the irrigation, so here what will happen? If I divide the number of hours, the millimeter by the total application rate, I'm going to get so it is coming to around 52 minutes. So I have to almost operate it for 1 hour. With the same, this is a 1 hectare plot and the same application rate, but it is a very hot day. So therefore, if I look at the number of hours that I need to irrigate, it will be 7 divided by 5.86. So roughly around 1 hour and 12 minutes. So that is the thing over here. Now let us look at the example. Now this is a plot of 125 meter by 80 meter. That is about 1 hectare. And the water source is a borewell. I have a 6 HP horsepower 8-stage submersible pump, and the borewell has got a better yield. It has got a yield of around 14,400 liters per hour, say 4 liters per second. And the depth of the borewell is around 30 meters, and you have the outlet size being 2 inches. and the water quality is normal with minimum silt, and the crop is that I want to irrigate both for germination as well as the growth of the crop is onion. And the grid of the micro sprinkler that I have of the mini sprinkler that I have considered is 9 meter by 9 meter. So here again the steps remain the same. So what is the first step? Let me decide that okay, I am going to have a mini sprinkler for this particular crop, and then I will have to decide the grid. So the grid that I am going to decide is 9 meter by 9 meter at 1.5 bar pressure, and I know that my mini sprinkler is going to give me 475 liters per hour, and the number of mini sprinklers that I will require over here now will be total area divided by the grid spacing. So same calculation. Here I'm going to take 10,000 as this area divided by 9 into 9. So I will recover 124 numbers of mini sprinklers. And we know that the discharge of each mini sprinkler is 475. So the total water required to operate the system will be 124 multiplied by 475, which is around 58,900 liters per hour. So this is the amount of water that is required if I want to operate all the 124 mini sprinklers. But what is the water that is available in my bore well? I have only 4 liters per second. That is 4 multiplied by 3,600 gives me 14,400 liters per hour. In other words, I have to create blocks. So how many blocks do I need to create? The discharge required by the total discharge that is available in the borewell. So 58,900 divided by 14,400, you get roughly 4.09. I'm taking it as 4 blocks. Like I told you last time, we have to go only for even type of blocks. You can go for odd blocks, but it's more convenient to do the layout in the field. So here again, the plot is 80 meters by 125 meters, and each block over here, the 1 hectare is being divided, and you have 4 valves, valve 1, valve 2, valve 3, valve 4. And like the beginning, I told you, at this stage, we have only decided the grid and what is the discharge of the mini sprinkler. I don't know the sizing of the main line, nor I know the sizing of the lateral line. So as usual, I will get into the lateral selection. Now, if I calculate how much water will flow in the lateral, you know, the length of the lateral is 125 meters, the total length. So 125 meters, if I divide it by 9 meter, which is the distance between each sprinkler, you are going to get 14 sprinklers from one end to the other end. And 14 sprinklers, each sprinkler is going to give a water of 475 required. So it works out to 6,650 liters. But 6,650 liters is for the entire length. Since I have divided it into 4 parts, it will become 6,650 divided by 4. So 1,662 liters per hour. That is the water required to be traveling in this lateral pipe. We know that the 32 millimeter plain lateral can go up to 1,800 liters per hour. So I have selected a 32 millimeter plain lateral over here to connect the mini sprinkler. So here my design now is I will provide these mini sprinklers at a 9 meter by 9 meter grid spacing using a 32 millimeter plain lateral. And now when we come to the submain selection, so you know that the submain, what is the water that is going to flow in each of these things. So since we have 120 divided by 4, 30 mini sprinklers have to be operated, and each mini sprinkler discharges 475. So 30 multiplied by 475 will give me 14,250 liters per hour. But what is the water that is available in the borewell? That is 14,400. So our design is also correct. So we know that 14,400 liters per hour from the selection chart, we know that we have to go for a minimum of 75 millimeter, and we will go for a 4 kg PVC or a HDP pipeline. And like I told you last time itself, we will not give the entire length as 75 in order to bring in the economy and also to bring in the discharge uniformity in the field. I will go for a telescopic submain. Telescopic ratio I have considered over here is 30%, and 63 mm I have taken around 70% for an economical design, because you know that the flow is maximum in the beginning. As it goes towards the end, the flow is going to taper off. It's a varied flow that is there, and so that is how the design has been completed. After the submain, I will have to design the main line, and the main line, we know that the flow in the borewell is 14,400 liters. I will either select a 75 millimeter 4 bar pipe, or I can choose one size higher, keeping in mind any expansion. Or if you are thinking of interconnecting 2 borewells, then I can go for a one size higher. And of course, over here, we have to go for the appropriate filter size. So we can go for a simple mesh filter, a plastic mesh filter, because plastic is very popular these days, and they are very convenient to fit. There is no rusting. And you can go for this plastic mesh filter. 3075 over here means 30,000 liters per hour. It has a filtration capacity. 75 is the inlet and outlet side. 75 means Actually, it is a 3-inch basically. And if there is any heavy silt load, then we may have to go for an additional hydrocyclone filter. So basically, based on the water quality, I have explained this in great detail in my earlier webinar. And here, basically, we are going for the simplest and the cost-effective mesh filter. Then coming to the head loss calculation, the calculations remain the same. So we need to find out how much head or pressure is required to run the system correctly. So we have 15 meters as the operating pressure for the mini sprinkler, and the operating the head loss that happens in the submain and lateral is around 10% of 15 meters, that is 3 meters. The motor is sitting at a depth of 30 meters, and screen filter will have a 2-meter head loss. And if I am going to apply fertilizers through the venturi, it will be another 5 meters, and fittings and accessories around 2 to 3 meters. And length of the main line, you know the length of the main line to the longest length, and 2.5% of that will be around 122.5 meters multiplied by 2.5 by 100 will give you 3.1. I've rounded it off to 4 meters. And elevation in this particular plot has been assumed, or if you have the Google map, you can take it, whatever is the minimum elevation from the lowest point to the highest point. So I've added around 3 meters. So the total dynamic head will work out to 65 meters in this case. So is my pump all right? Now I have the submersible pump with the various stages. You can see the impellers over here. This is a 6 HP pump and a 8-stage thing. And I told you one stage is around 9 meters lift. So 8 multiplied by 9 is around 72 meters. Head available is 72 meters and head required is 65 meters. So the existing pump is very much suitable from the point of the head. Now I have to check for the HP. So when I want to check for the HP, the horsepower formula that is there. So Q into H divided by 75 into 0.7 into 0.8. You can take even efficiency of 0.6, or you can take an efficiency of 0.87, so 0.56, no problem, that is 56%. The discharge in this case is 4 liters per second, and the operating head that is required is 65. 4 multiplied by, it should have been 65 over here, 4 multiplied by 65 divided by 75 into 0.6 will work out to 66 HP pump. So the existing pump in terms of horsepower is also adequately enough. So that completes actually my presentation on both the micro and the mini sprinkler irrigation system. So I am open to any questions that you may have. Thank you very much.
Thank you, Mr. Vijay Kumar, for the detailed presentation. I'll now take up some questions.
Yes.
You can stop sharing the
screen
and you can on your video.
Yeah. I think you're going to.
The first question is, First question is, for which crops is sprinkler irrigation most suitable?
Sprinkler irrigation is very much suitable for all type of field crops. Basically, you will find that you can irrigate any kind of field crop. You can irrigate pulses, you can irrigate ragi, you can irrigate all millets, you can irrigate corn, all field crops where the spacing is very close, and all vegetables. So that is where this system is very much useful.
And next question is, does sprinkler irrigation use more water than drip irrigation?
Yes, sprinkler irrigation, since it is going to throw water in the whole area compared to a drip irrigation system, this is a very tricky question in the sense we'll have to really work it out. But generally what we say is, if you are going to have a portable sprinkler irrigation system, it is going to consume less water. But in terms of the water application that you are going to give, whether you give it by drip or sprinkler, the sprinkler irrigation definitely is going to consume more water. And the drip irrigation, generally, if you go for a 2 liter per hour discharge drip irrigation, it will consume a lesser quantity of water.
Okay. And next question is, summing up, what are the main points a farmer must keep in mind to design an economical sprinkler?
Yeah, in order to do a design of a sprinkler irrigation system, first is he should know what is the area that he wants to irrigate, and then he should know the soil type. That is very important. And you should select a sprinkler that is suitable to your land. For example, if your soil is going to be a clay kind of soil, you should take a low discharge sprinkler. Whereas if you are going to have, your soil is going to have a sandy kind of soil, and where the water is going in very fast, then maybe you have to increase the discharge a little bit for your sprinkler. But then you are going to control the amount of water that is infiltrating by adjusting the duration of your sprinkler. So that is very important. Look at the soil type, look at the kind of nozzle that you want to have, and the nozzle should be selected that it is very economical. It's very easy to open and clean it. If there is some small silt particle has come in spite of the filtration, it should be able to open it up and clean it up easily. And it should give a minimum life period of at least around 10 years.
Okay.
So the product quality has to be good.
Okay. What is the new irrigation technology today?
The new irrigation technology is now all these sprinkler irrigation. And if you go to the foreign countries, you will find what is called as a pivot irrigation sprinkler. They are basically the same sprinkler irrigation, which is automated. And also now you will find that drip irrigation has gone into subsurface drip irrigation, and everything now is getting into automation. Automation in the sense you have automation, you have both automation which is timer based, or you can have a sensor based, or you can have a real time based. And you can also go into what is called as NDVI measurement. So what is the normalized, so based on the color of the leaf itself, you can decide whether my irrigation has to be started. You can actually you can exactly precisely, for example, like we have taken on a cool day, it is going to be 5 millimeters. On a hot day, it's going to be 7 millimeters. In real time, with all these NDVI parameters and what we call as the artificial intelligence coming into picture, and with precision agriculture or precision irrigation, we can definitely go into giving real time. So you can tell exactly so many minutes, and the whole thing is automated, and the computer will switch on using Internet of Things. The area will exactly get irrigated to whatever time you require. And suppose it's a rainy day on a particular day, the irrigation will not happen. So you don't need to irrigate, isn't it? So you have sensors in the field which will check the moisture level, which will check the level in the atmosphere. It will also check what is your leaf condition, is my irrigation adequate or not adequate. So now it has moved into a totally different plane altogether.
Okay. Next question is, how is India's irrigation technology compared to irrigation technology in Israel?
The Indian technology that we have, most of the drippers and things, it is very much comparable with what is available in Israel. Though Israel, we have to give credit to Israel because they were the inventors of the drip irrigation system. They are in the forefront of developing later and later technologies. Not that we have taken their technologies and brought it to India, and you have very good technology available in the Europe, you have in the US. And so all systems and Indian systems are no less, they are also equally good. And basically what over here matters is the kind of design of the product in terms of the nozzles or the drippers. So I think it's very much comparable. But then, of course, the cutting edge technologies are definitely there in Israel. And Israel has been a very big, huge partner with India. And over years, there are many companies that are working over here in India. And there are many Jordanian companies also working with us. And so that way, this technology that is there and the products that are available are very much comparable. And no doubt we can use both the products.
Okay. And next question is, how long you have been with Premier Irrigation, and what do you like most about your job?
Oh, that's a very personal question. Anyway, no problem. I have been with Premier Irrigation for the last 20 years, and I have been in the field of micro irrigation for the last 32 years. I started my career way back in 1987. And all throughout this 32 years, I've been totally associated with micro irrigation only. And the main reason I have been in this is that I would like to share my knowledge with the farmers. Whatever I have learned, I didn't learn because I'm basically a civil engineer with a post graduation in hydraulics and water management. We learn a lot of theory, but when we come into the field and the field experience that is there, most of this knowledge is not getting percolated down to particularly to the farmers and the field people. So teaching is one of my hobbies, and I love to teach and I love to share knowledge. During the earlier days, I struggled a lot to learn. In fact, whatever design I'm telling you is you will not find it in any textbook. These are design modules that have been designed by myself based on my field experience, and I have made very simple thumb rule methods which are working very fine. And we have trained so many dealers and staff, more than 4,000, 5,000 people across this last 32 years. So I love teaching and training my people, and any farmer, any any individual, any dealer, anyone who is interested to learn. Thank you so much.
Okay, that's very good to know and very inspiring. And now we have the last question. What advice can you give to young graduates wanting to work in agri input companies?
Actually, there has been a mad rush into getting into the technology sector. Like I'm not telling that it is right or wrong. People parents want to send their children mainly into the IT related or the electronic related. But I would say agriculture per se is a very good line. And the next 10 years, it is going to be the ag revolution, because you are going to get a lot of interface of IT into agriculture. For example, drones are coming in. You're going to have Internet of Things. You're going to have automation. You're going to have timer based. You're going to have sense of real time based. You're going to have LoRaWAN technology coming in. So a lot of technology is coming in and a lot of opportunities. Just when I look at the micro irrigation, this is just one part. There are so many other areas where now everything is going to be automated. You're going to have robots. You're going to have tractors being run without any manpower. Only robots are going to run. So agriculture and technology is going to be the next big thing in the entire ag revolution. So the IT revolution was there in the vision of Prime Minister Ji. Definitely the next 10 years is going to be the vision of ag revolution, or we can call it as the ag tech revolution. And I think I would urge all youngsters, and particularly the parents of youngsters, to look at this as a viable option. People shy away thinking that it is not, you don't get paid properly or you don't have opportunity here. Actually, you are going to be with nature. You're going to be moving around with the farmers. You're going to be interacting rather than sitting in a wall and sitting in front of the laptop. I think I would urge youngsters to go out and be in the field, interact with the farmers, and also come back. You will have a mix of both the field life as well as the office life. You will have laptops, you will have iPads, you will use technology. At the same time, you will be with nature. One of the main reasons I stuck on in this line is because I love to be with nature, love to be with farmers. So someone who has got a passion of being with farmers, with nature, and also be technically good, I think this would be a very beautiful line to take on. And I would urge all the youngsters to take up this as one very good profession.
Okay. 1 second. Okay, Mr. Vijay Kumar, I am not seeing any more questions from participants. Before we end, let me check with the participants here we have in Zoom. Mr. Dilip, Mr. Mohan Kumar, Mr. Sanjay, if you have any questions, you can post it, you can ask, or you can post them. And Mr. Robo. Yes,
No,
Mr.
madam,
Mohan.
No, madam, no questions.
No questions, okay.
Yes.
Mr. Dilip, if you are
madam, no questions from me.
Okay. And Mr. Robo and Mr. Sanjay, if your mic is not having any issues or you don't need to, okay.
No question, ma'am.
Okay. Okay, Mr. Vijay Kumar, now we have come to end of question round. On behalf of agricultureinformation.com, I like to thank Mr. Vijay Kumar for a very detailed presentation and answering all the questions in depth. And I also like to thank all the participants for joining this meeting. The meeting will now be closed.
Yeah, thank you very much, madam, for giving me the opportunity the 5th time. And I would like to contribute to agri information, and we'll conduct many more webinars. There are many nice topics, small topics we'll take up, and we will share this knowledge to all our farmers. And that will help us. Okay. Thank you very much.
Thank you, ma'am. Thank you, sir.
Thank
You're
you.
most welcome.
Sir.
Thank you all.
Thank you.